as the topic says, this topic I would be not getting too much to the graphing stuff, but the use case stuff I would highlight. Okay, so the good thing when we whenever we start is okay, maybe sorry. So what we will discussing in this session, obviously my introduction, then what motivates me to be here and talk about this thing, and why this thing I think is viable and we should care about this thing, and how and what, and then we will discuss along with one or two examples so we can get actually the highlights. So actually this thing works. This is not just theory or just philosophical thing. Actually this thing works in life also. Okay, so this is my short introduction. Actually I am back from Pakistan. Currently I am doing PhD in computer science from University of Urbino Carlo Bo in Italy. So I fly yesterday, long journey to just give this talk. Okay, so this is the only day which I am attending here and to give and to share my insights with you guys. Okay, my research group with whom I am working is ANANSI, Analysis of Network and Simulation Research Group. We actually working on decentralized systems like blockchain technologies, and I'm the only one guy who knows knowledge graphs, so I'm the one who will be integrating knowledge graph stuff with decentralized system, which we already had. Okay, and why not to connect, because everyone wants to connect, so I'm here to get connected. So this is my LinkedIn link if you want, or you can only Google Siraj Munir. I hope you will find Google knows me well. Okay, so the agenda or the basic idea or the fundamental behind this talk is we already have data, okay, and what knowledge graphs or what ontologies or what semantic technologies does, it helps us to find the patterns which are already residing inside our data. So we will be trying, or I will be trying to explore or trying to explain how can we basically use this data and find meaningful patterns, or maybe for future they can be meaningful for us, and specifically knowledge graphs, not the ontologies. Why not ontologies? I will discuss. Okay. The motivation, what led me to think about this topic and try to start with this topic is when I read a book, Everybody Lies by Seth Steffen, just like about 2 months ago, when one of my friend told me, he's actually philosopher, he told me that there's a book and it's a good read, you can give it a try. So I read that book, and from that book I got an idea. So we have data, we have patterns, so why not we integrate this thing with graph technologies and maybe make it more useful or more helpful for the community, for ourselves, for the researchers, or for end users. And the next thing is what is the strength or when we talk about generalization, or we want to generalize technology or generalize graphs for people, so how knowledge graphs can help in that stuff. And then obviously last not the least, so what is the insight on the basis of which I want to show this, or I think this thing is viable, or this thing is useful for people to know, okay, this thing is available and we can use this. Okay, with great power comes great responsibility. The great Uncle Ben, Spider-Man. So I got this thing from this him. Okay, according to me, what is viability? I tried to explain this thing with these three fundamental concepts. If you want to think, or if you want to see or explore if the thing is viable or not, these are the 3 points according to me, according to my knowledge, that can help you out to justify the thing or whatever the technology, the stuff, either it is viable or not. Okay, the first thing is what it takes. what technology stuff, what background, what knowledge, what infrastructure it requires to get you started. How probable, if you get the stuff on your hand, and if you grab the technology, if you get the technology stuff and you have the infrastructure, XYZ, everything, how probable is it will give you good insight? And finally, based on the probability and based on the probable chances, you will see what it gives. Okay, because we have obviously we have expectations from things, and it's always not true that we get what we expect. This is what research about is. We think, okay, this can be done like this, there are many ways we can explore this, and eventually at the end of the day we are with no results. Sometimes, but not always, but this happens, especially in research cases. I would be using two data sets or two short data sets extracted from Google Trends. One data set is based on cricket, because I like cricket, so I know Americans know it, but so I thought this example would be useful. So it's generic, and the other example is so related to America, and it's based on political sense. And so what was a keyword, or what keywords people search when there are elections or the campaigns are going on. So we are trying to explore what can we do with this thing. Okay, just for the demonstration purpose, this is just a time series, or if you don't know what is time series is the analysis of data what you have based on the dates or time log. Okay, so this is the trend from Feb 22 on this year to the May 8. Okay, and this trend show different keywords based what people have searched about, or what personalities people have searched about. Okay, why I'm using the Google Trend dataset? Because it represents whatever we are searching or what we are typing. It shows ourselves. Okay, and we can lie to people. Okay, like everybody lies, but data does not. Data shows you the actual trend or actual meaning or actual thing that is going behind the scene. Okay, I can say I'm not anything, but my search history or my keylog will show what I am actually. And this is just again a comparison between two personalities, Joe Biden and Donald Trump. Again, this data is also political, so I'm not going to emphasize on political stuff. I'm not here to justify politics, but just to give an example and to get an idea. Okay, so from where this knowledge graph thing or knowledge graph stuffs come? Okay, we know graphs are everywhere, and we want to integrate graphs with everything, because graphs are so generalized that makes them so powerful that we can integrate them to anything. There's famous saying of my professor, not by any well-known scholar or anything. He says, whatever you are searching or whatever you want to think, you need to wear the glasses of that thing. Like I'm wearing glasses, because I want to see you guys. And if anyone has eyesight effect, so he's wearing glasses so he can see me or see the world. So same lies here. If we want to explore the world or whatever we want, whatever the aspect we want, we have to wear the glasses of that thing. And then we will start or we will begin the things the way that technology will work. Like if I want to emphasize on ontologies, I need to wear the glasses of ontology, and then I can say, okay, this is the ontological world, this is top level, this is bottom level, and there are different things we can build upon and we can do. And if I'm like engineer, I can see the world with the eye of engineer. If I'm philosopher, I can see the world with the eye of philosopher. So whatever you are, whoever you are wearing actually the glasses of that thing, the domain or the field or the background you belong. So whatever you search, whatever you think, it's actually based on your background or what you are having, or your thoughts are coming in your mind. So for me, the knowledge graph is basically helps you to integrate the real world entities with your technology. Okay, there are different concepts, different definitions, because I'm a researcher, so I think everything, what is the definition behind this, because the definition justifies what the actually thing is. So based on the definition, you can, okay, this is the thing and this is what we are trying to do. So there are different definitions, and I will tell what definition I like and why. Okay, starting with the first definition, which is by Google, and it was published on a blog in 2012. The term knowledge graph was already there from like decades, but it was not famous until unless Google recalled and coined this term again with the concrete real world scenario that they are currently using. And we can see, and we already use it, but maybe or may not, or maybe we know it's actually this knowledge is the knowledge we are getting from knowledge graphs. Okay, so why Google used knowledge graphs? Google used knowledge graph for its search result, because obviously it's the search engine, so it wants to enhance its search results for the people who are using its results. So it can give you better insight or better results whenever you are searching on the specific keyword. So according to Google, the knowledge graph is just a knowledge base, okay? And the knowledge base, if you don't know, knowledge base is the collection of facts and truth values that specifically belongs to the relationships, or maybe not relationships, just the data. Like all men are Socrates. This is true. This is universal truth. And sunrise from east, and this is also universal truth. So the things that are already there or that are universal truth, so we can basically use those things and build knowledge bases. And generally, they are now currently in today's world, there are more definitions to the knowledge bases, but I'm not going to in the details of those, but just to emphasize this definition. According to the Elsewhere, which is a research journal publication, they have many research journals and highly impact factor and worldwide well known for researchers. According to them, knowledge graph is a model which basically helps you to specify the representation of relationship between the data and the knowledge entities. And entities, according to me, or according to the knowledge graph, are real world entities, like people, like things. It can be anything, but it exists in the real world. It's not, it will not exist in the hypothetical world. So it will be existing in our real world and have some relationship, or can be mapped with some relationships. And the relationships which knowledge graph use are known as triples. Okay, so triple is basically built on three things. You have subject, you have predicate, and you have relationship. So whatever the subject is, whatever the object is, you are basically connecting with the help of predicate. So the predicate expresses in Neo4j terms relationship. Okay. And according to some blog on Wikipedia, because Wikipedia has many blogs, so maybe it's true or maybe it's not. We cannot so trustworthy on it. But according to Wikipedia, knowledge graph is just a knowledge base based on graph structure. So you have some sort of model topology or some connection or some infrastructure, and you are basically integrating it. So from where this knowledge graph term came, for that stuff I would like to emphasize on this figure. And this figure is well known if you know semantic web. This is semantic tower. If you search on Google semantic tower and click on figures or images, you will find this figure. Okay, what this figure shows to us, okay, and There are different layers of data for web, for connecting the web, because we are talking about the web, and it's not just for the web. It could be for people, it could be for any use case where you are trying to basically implement the semantic technologies. So this is the basically fundamental line or background for what you from where semantic technologies are being came from, and currently still this model is valid. Okay, so essentially what we are trying to do, we have always data, and data is what we are based on, and everything requires data. Either you want to go for machine learning, either you want to go for data science stuff, or any stuff, you require data. And for data, you need, according to semantic web, you need some encoding schemes or some mechanism through which you can make a platform or provide a platform or data integrity platform, what we can say. And that is, when we talk in web sense, it's URI or URL, what we have, like google.com, neo4j.com, or any other. And this Unicode basically provides us the layer which is same across every platform. Either you are using Windows, either you are using mobile device, either you are using tablet mobile, or anything, whatever the device is, this thing remains same. So what semantic web says, or what semantic web fundamental says, we require such representation of data which can help us to make a layer or make the data spread in same format. So we can have, or we can retrieve same records when we are searching anything or we are trying to explore something. Next thing, obviously, just raw data cannot make sense for machines, maybe for humans. Maybe we can read some text and we can summarize what is inside it, or we can explore some key points from it, but machines cannot. For making machines to understand that data, we need a schema. Okay, and fundamentally, or in the old days, XAML was used for this thing. XAML basically helps you to provide the schema, what your web page or what your the data you are having represents. And based on this schema, you can basically add a layer of graph, which is here is RDF. RDF is resource was proposed by World Consortium W3C, which is the main body behind the scene or behind semantic web technologies. So RDF is also just like a graph, or you can say it ontology. Ontology is also a graph, or in short, it's a domain specific graph. So for making ontologies, you have to be domain specific, and you have to grab some domain expertise. Then you can basically build ontologies on top of it. Without domain knowledge, you cannot basically extract what are the foundations or what are the key requirements for that specific domain that can be used for expressing that use case or that domain. Let's take an example for ontology modeling. Let's say we are working in a company like Neo4j, okay, and Neo4j has different departments, okay. But which department works on which technology, and which departments, how these departments are connected with each other, you cannot know if you don't work inside Neo4j, unless you are outside Neo4j, like I am. I just know that Neo4j is a company that is working on graph technology, that is working on graph data science stuff, that is working on different researches and different stuff. But I don't know on which company, on which team Michael Hunger works, on which team Mr. XYZ works. So unless I don't have domain knowledge, I cannot explain this thing. So that is the fundamental of ontology. To express any domain or to model any domain with the help of graphs, you need to have, or you need to achieve the fundamental or the domain expertise. But the knowledge graphs helps you in this stuff. If you don't have domain expertise, you can make them on the go. As you are getting data from real world, you can integrate it on the go. That's why knowledge graphs are famous. And that's why knowledge graphs helps you to model domains quickly and easily. So we start with the raw thought, obviously not so random, but we have something like we can say, okay, Neo4j is a graph company. Like starting point can be this for knowledge graph. And then on the go we can make, okay, we have engineering team, we have QA team, we have different teams, and we can integrate those teams. And as we integrate more knowledge, our graph will increase. And here the knowledge, by knowledge I mean the relationships, which we are basically integrating, okay? And then there is a layer of logic. Logic basically helps you to drive the rules on the basis, on what basis your data will be retrieved when you will query over that data. And proof and trust, I would go in details, but it's more about governance. Like if you have data, so what is the proof? What is the footprint of that data? So we can prove where this data is coming from. Is this data authentic, or can we trust it is trustworthy, and that stuff. There is a lot of room in these top 2 layers. But the layers we are having like 4 layers beneath them. They are basically where the world is working currently. And ontologies are there like from like 40 to 50 years, and still people are exploring its power and basically integrating them and still getting results and making achievements. Like today, Jim Weber also shows ontological representation, and he says, okay, we can basically build this thing, and we are basically, our next target is to work on such stuff where we have anonymized data graphs or anonymous nodes, and we can basically integrate them and make some use of it. For making our use case concrete, we need to establish a graph model. So this is the simplest graph model which we have. We have a person, or we have a profile of a person, and this profile represent here not his personal or her personal profile, but her or his search history. And this is the information which I have extracted from different sources, and that's why I have randomized it. So I don't want to get in the privacy concerns, so that's why I have what we can say hashed it, so we can not see the actual personality, but we can see what insights we can have. Okay, so for that thing I would like to switch my screen and show you some running example, so we can actually see what the things are going on. Okay. Okay. I have made 2 notebooks to show what we can do with this data set. Okay, let me also hit the engine. Meanwhile, we can discuss the notebooks. Okay. These are the references or sources from where I got help in code. Okay. So this is not from, the code is not holistically from me. I took help from some blogs, so we can basically extract results. And these are the same results which I have already shown you on the slides. So this is the actual code behind those graphs or those plots we have extracted. Not graphs, those were the plots. And we will see how knowledge graphs can help us to map these plots into a graph. So this is a simple with the help of Google Trend, we can basically extract data or information based on keywords. It can be anything that is actually available on Google. So we can basically hit that keyword and extract the information related to the keyword. So I tried cricket keyword for the first. So it gave me some results, like what is the trending and what is the top level score of this thing, and from which locality these results are belonging. So locality is important for us. So we actually want to explore which locality is interested in such type of information. So we can get basically journal mindset of that population. So we can basically, maybe in future we can make network analysis, social network analysis, community extraction, and that stuff. So because cricket is mostly watched in the South Asian region, in India, Bangladesh, and Pakistan, in that area. So these keywords are basically extracted from India, and they have higher hits as compared to the other regions from across the globe. So live cricket IPL. IPL is the basically league which is organized in India. It is International Premier Indian Premier League, which is one of the famous, if you ever have experience of watching cricket. So, and this is there are some player names also, like Babar Azam. He's captain of Pakistan cricket team, and maybe some people are search for streaming channels like Sony Live. It's the name of a channel, TV channel, which basically streams as well. And this is the just a summary view of the whole search. Like, what is the keyword which is on the top? What is the score, if our scoring mechanism, whatever it is, and what is its related query which people use to extract this keyword. Like live cricket IPL, it belongs to the query live cricket. So if I'm searching for live cricket, or I hit live cricket on Google, it will most probably relates me to the live cricket IPL, and it will extract the results of this specific keyword. And similarly, we can have more keywords or complex keywords. Like here I have shown multiple keywords like coronavirus, Donald Trump, Joe Biden, China, elections, and these are also what is the probability on which dates people have visited or searched these keywords. This is just to show and to give an idea what this thing can do, or what this tool can do, specifically PyTrend. Okay. So this is the plot we actually see in the figure, and we can see on which date or specific time this results, this spike or this keywords or this specific keyword was searched the most. So we can basically extract which keyword is on trending, and on the base of those keywords we can basically make recommendations, maybe some product recommendations also, maybe some should you buy like Netflix campaign or like that, something like that. Okay. And these are the actually links which help us to integrate. This is actually the knowledge we will be using in the knowledge graphs to make this thing work. Okay. Later, let me open. Okay. Let me just give an idea what we have. Keyword with the keyword. Okay. So this is basically sort of short knowledge we have. This is not the huge knowledge graph, but I have just made it to just a representation to show how this thing can be useful. Like there are some person, the brown nodes are people like LS Bob and I, because I can represent myself. So, and these are the keywords which different people search about, like Neil Boys, Donald Trump, and stuff like that. And each keyword has some relationships, some web links connected with it. So with whatever the person is searching, like I am searching like for Donald Trump, so which links I will visit, or which links I am trying to explore. So based on this knowledge, we can basically enhance the results. So if I'm interested in like politics, like we got news feeds from Google, or we got news feed from different websites, so we can basically make more generalized, more better results, more better recommendation for our news feeds with the help of use case like this. So we can have, if I'm interested in politics, so and I'm belonging to a specific locality, so I should be getting the news from that specific locality and getting specific results which I am interested the most, not the generalized one like currently Google or Microsoft does. And also, obviously, because this is a graph, we can basically find the relationships between them. So, okay, sorry, this one is not, let me, I have already modeled some QEs, so we can basically see what we can do with this pattern. Okay, with the help of this such use cases or such data, we can also find missing links like we do in link prediction task. So if two persons are not connected or two persons have no relationship directly with each other, but with the help of keywords or with the help of their search patterns, we can basically integrate them and we can use this data to make more better results or recommend more better to them. And this is all, these are people basically use this data. So final thing, so these are the three potential use cases which I think where we can map this knowledge or this information what I have tried to show. This is these are just not the use cases which are the only possible use cases. There can be many more, but these are just examples or which I think can be utilized. For search engine optimization, because search engine optimization is totally based on keywords. So if we can get better keywords, we can make websites or we can use those keywords to rank our websites higher. And second, the recommendation system, so we can basically recommend better news feeds, better products, better things. And finally, not by the help of these two things, we can have better search results for the people and for the community. That's all from my end. If you have any question, you can ask. Thank you.